we are now entering multi-step equation, solving multi-step equation. So you saw the video before, it said solving multi-step equation, but really it was sort of like the front feeder that sort of talked about like terms. Because the difference between a multi-step equation and a two-step equation just is the very word itself, multi, meaning more than one. There's more than one step. There's more than two steps. It's multi. So the things that we need to know by the end of this lesson is I can solve equations for a variable, which we think we know, but we're going to have a little bit more difficult problems. And the second thing is I can identify the parts of the equation. We've actually already done this. This is how we've been solving the equation. We've been circling the variable, that's identifying a part, the coefficient, the constant, circling the equal sign to separate two sides. So we've kind of already know how to do this, but we're just going to make sure we do. And at the end of this, if you don't know how to do this, then you need to blame Miss Garcia and email her. Anyway, just kidding. So that is true. So we talked about, to simplify equation, we talked about GEMDOS. We talked about grouping symbols, exponents, multiplication, division, adding, subtraction. But we know that multiplication and division and adding and subtraction happen whatever you see first as you approach from left to right. But believe it or not, to solve, you undo that. And I'm going to prove that to you in these videos. So we use something called SADMEG for that. So instead of GEMDOS, if you flipped it around, you end up with SADMEG. Now, I'll get to that, but for right now, I really want you to take time, and I want you to go ahead and pause the video, and I want you to write these notes. Do it now. I'm watching. Okay, I hope that you actually paused and wrote these notes down, because if you didn't, you're one crazy fast writer. So, we know that to solve a two-step equation and a multi-step equation contains more than one operation. So, in the past, you've actually only seen the step one. Let me just do some circling here. We've done the step one, which was to get rid of the constant. And then we did the step two that gets rid of the coefficient. Those rules stay. So we didn't want to change the steps. So what we did is we introduced something called step 0. And we called that simplify. And what we mean by simplifying, it sounds like flossing. What we mean by simplifying is that sometimes the equations look kind of mumble-jumbled, and so you have to do the distribution property, or you have to combine like terms, and that's why the lesson you saw before this was showing you about those like terms. So let's go straight into a lesson and put this stuff to work. So let's go ahead and do that. So what you see right here is an equation. And right off the bat, I noticed something weird. What do you guys notice that's weird?
It's backwards.
It's backwards, that's one thing, but that shouldn't matter. What else do you notice?
Not simplified.
It's not simplified. There are two variables here. So usually when we go to solve an equation, we start off by circling the variable. But because there's more than one variable here, we're going to have to go, and that's where that step 0 comes in. And that step 0 was simplify. And so if we're simplifying, what's that look on your face for? Scare me. If we're having to simplify, that means that we have to do what Mr. Nelson said and Miss Johnson did again. Johnson, you're dead to me. Miss Garcia said, is to find the like terms. And so first thing I do is I look through and I say, okay, I see a 3m, I see a positive 2m. Those are like terms. So I can add this together. And I can add them together. You can actually rewrite this equation and write 3m plus 2m minus 2 minus 7. And what that property is called the associative property of addition that allows us 5 plus 2 is the same as 2 plus 5. So it allows us to move the equation around. And so that's how, we're not doing some kind of magic math stuff where we're like, oh, I'm magically moving around. This is actually a property you can do. But a lot of us actually don't even do this process. We just go, oh, 3m and 2m are like terms, and we know that that equals to 5m. Right? And we see that negative 2 and negative 7, those are both constants, and they can be simplified, and that gives us negative 9. That's not a 7. Shush, that's the most beautiful 9 you've ever seen in your life. That's like the Mona Lisa of 9s. All right, so there is our equation. Now, the reason why we can do this is because of the associative property, but we don't necessarily have to write all the steps down because it takes forever. We can just do a little bit of arrow language there, or just showing the combination. So, now we have simplified. We've done the step 0, so now we can do step 1, which is to identify the constant. Though it's well, before I do that, though, who's forgetting?
Ba-dum-bum-bum.
Lollipop. lollipop, oh, lolly, lollipop, lollipop. What we have to do here is take that equal sign and divide the equation into two sides. This way I can make sure what I'm doing to one side I'm doing to the other. So, first thing I'm going to do is I'm going to circle the variable, and up here there were two of the same variable, but down here when we simplified it and added like terms, which is our step 0, we now only have one variable, and the variable is m. And so we circle it. That's our step 1, right? Identifying the parts. We've circled the variable. Next, we have to underline the coefficient. Here we had two coefficients, but because we simplified it, now it's very simple. Coefficient is what touches the variable. It's that creepy dude. You can always tell when somebody's touching you. Like, no, don't touch me. Right? So what's touching the m? 5. So this is the coefficient. And then double underline the constant. We have two constants. We have 1 and -9. However, because we divided the sides, and we know we're only dealing on the side where the variable is, we only have one constant we need to think about, and that's the -9. And so now we have circled, underlined, double underlined, and it's 2, 1, 0. We've got the answer, right? 2, 1, 0. So 2 would be get rid of the double lines. That's the constant -9. How do we do that? The opposite of -9 is?
Add.
That's the addition property of equalities, which says if I add 9 to one side, I have to keep the equation equal, add 9 to the other. Or else that balance beam is off. -9 plus 9 is 0. So that goes away. I could write a 0, but that's kind of a waste of time. I'll bring down the 5m. And 1 plus 9 is 10. And so now I've taken care of step 2. Now I got to go to step 1, which is get rid of the coefficient. The coefficient is 5 times m. So how do I get rid of times 5?
Divide by 5.
The opposite of times is divide. So I divide this side by 5. That's what this line here means. It means divide. And I divide this side by 5. 5 divided by 5 is 1. But I don't need to write that 1. This 0 and this 1 just kind of remind me of these things. So I actually have 1m, but I'm just going to write the m. And then 10 divided by 5 is 2. And so 2 lines, 1 line, 0. We have the solution. Now,
Mr. Craig,
yes.
do we have to write m equals 2?
That's a great question. Now, that technically is the correct answer. But on Canvas, our activities, and sometimes on end-of-the-year tests, if you write that down as the answer, the computer doesn't know, like, oh, that's this 2 equals m is the same as m equals 2. Can anybody tell me what that property is called? So, m equals 2 is the same as 2 equals m. This is actually the way most people like to see it, reading it from left to right. The variable equals something because it's just a simpler form. Okay. Since I am obviously losing my mind, Mr. Nelson to come up here and save the day. Go ahead, Mr. Nelson.
All right.
Play that funky music.
So you notice you got the same problem up here twice. We're just going to show you both ways. Again, we're going to start with the steps. Step 0, 1, and 2. Simplify, get rid of your constant, get rid of your coefficient. And then we're going to show you guys how to do it just using StatMeg. All right, so let's start off over here. Remember that step 0 is to simplify. And simplifying is really kind of two things. It's distribution and combining like terms. So let's ask ourselves, do we have any distribution in this problem?
Yes.
Yeah, what do I need to distribute?
4.
4. The 4 is going to distribute to both terms. Now this is using arrow language. We're going to show you guys some awesome tricks with that later. So distribution is a process of multiplication. So it's going to be 4 times n, which we'll just say is 4n. 4 times 3?
12.
12 equals?
12.
12. Ooh.
Ooh.
Nice. So we have 4n plus 12 equals 12. That's step 0. Oh, I mean, we should check to make sure that we don't have any like terms. So let's do that. Do I have any like terms over here?
No.
And do I have any like terms on this side of the equation?
No.
Now-
Isn't 12 the same as 12?
Yeah, and that's what I was about to address. Because these two numbers are constants, they are like terms, but do I care that they're like terms in this case? No, because they are on opposite sides of the equation, so I don't care, right? So let's back up here just a smidge. There are no like terms over here. That's what I asked myself. Are there any like terms on this side? No. Are there any like terms on this side of the equation?
No.
No. And now I can start saying, hey, I've simplified. Let's move on. Let's get that lollipop in here and start identifying our parts. First, what's our variable?
And because it's a letter.
And because it's our letter, right? What's our coefficient?
It's the thing touching the variable.
It's the 4.
The plus?
No, that's not the
Oh.
number. That's an operation.
4. And then the constant?
12.
12.
Both of them.
12. Double underline that, right? And now we just got to do 2, 1, 0. But really, we're just going to follow the steps here. We got to get rid of the constant. That's step 1. Get rid of the constant, and that's what we just identified. So how do I get rid of the constant? Positive 12 plus 12. So we get rid of plus 12 by subtracting 12, the subtraction property.
of equality.
The equality. And if I subtract it off of the left-hand side, got to take it off of the right-hand side. Now what I have left is 12 minus 12, which is 0.
That's right.
Okay. I'm going to bring down everything I have left. You'll notice I'm bringing it straight down to stay organized. And then 12 minus 12 is?
It's a 0.
So do I not have to write that?
That's a good question. Do I just leave this side blank, or do I write 0?
That would be.
It's got to equal something.
It's got to equal something, so we are going to write the 0 here, okay? Here's your 0. I wrote zeros backwards.
Goes like this.
So I have 4n equals 0. Now what do I need to do?
Get rid of the coefficient?
That's the last step. Remember, simplify, get rid of the constant, and get rid of the coefficient. We identified the coefficient as 4 up here. So how do I get rid of the coefficient 4 if it's really 4 times n?
Divide.
Division property of equality.
Which means I have to divide both sides by 4.
Oh, 4.
Is
There
that
we go.
no solution?
Good question. Let's keep working from left to right here.
Sorry.
What's 4 divided by 4?
1.
Oh, 1.
4 divided by 4 is
1.
1. So I'm just have 1n. Do I need to write the 1 in front of it? No, because I have 1n there, right? Equals, what is 0 divided by 4?
0.
Mr. Craig doesn't know that one.
Oh.
So
I'm confused.
n equals 0. Now, this is the one that gets people confused. 0 divided by 4 is 0. The one you can't do is 4 divided by 0.
Yeah.
That's the no-no. Okay?
That's a no-no.
0 divided by any number is going to be
0.
0. Okay?
Okay.
All right, so that's taking the steps, right? Simplifying, get rid of the constant, get rid of the coefficient. Let's go now through SADMEG. Now, this is where it's going to change just slightly. SADMEG starts off by saying, we're going straight to solving. We're not going to simplify. SADMEG, we're going to start with our subtraction and addition. Now, a lot of people go, well, where's the subtraction and addition? There's addition right here, but can I touch that addition right now?
No, because I don't know what it is.
Well,
Well, it's inside the print.
it's inside our grouping symbols. And if it's inside our grouping symbols, we're not there yet, are we?
Oh.
That means grouping symbols got to come last. So we can't actually touch this subtraction and addition until we can get inside the parentheses. And we can't right now. We got to get rid of those.
That's so sad.
So we're going to move on, because we can't touch that subtraction or addition, and move on to our
DMs.
DMs, our divisions and our multiplications, right? Is there any division or multiplication going on?
4.
There is a 4, because 4 times n plus 3, right? That's where we would distribute normally and simplifying. I'm going to skip that step, because it's actually going to make this a little bit shorter, as you'll see. So instead of distributing, how can I undo multiplying by 4?
Divide.
Vision.
Divide, but what am I going to have to do when I divide?
Divide
Both sides.
So what do I need?
Lollipop.
Lollipop to remind me.
Boom, boom, boom.
Yes. So I've got a lollipop here, and now I'm going to divide both sides by
4.
4. Now make sure that you divide everything by 4. Everything on both sides. What is going to happen on the left-hand side with this 4 and that 4?
Oh, it's 1.
4 divided by 4 is 1.
But if you divide everything, aren't you dividing the n and the 3 too?
Well, because there is a factor here, and because it's already out here multiplying, and because both of those are just 2 factors, we're going to just cancel these out to 1.
Oh, so it's gone.
Yep. If I were to divide this 4 by 4 and this n plus 3 by 4, I will have divided this side twice by 4, and this side only once, which would not be equal. Over here, let's actually write down what we have left. We have n plus 3. We're going to talk about these parentheses here in just a second. And then 12 divided by 4 is 3.
Jinx.
Wow, jinx. Somebody. Oh. So I have n plus 3 equals 3. So what about these grouping symbols, right? And we can move on here. Exponents. Do I have any exponents?
No.
No, which moves us to our grouping symbols. How in the world do I get rid of those grouping symbols?
Everything's gone.
Yeah, do I need them? Yeah, there's nothing outside touching the parentheses. There's nothing, it's not being divided by anything. So do I even need those parentheses? No, we don't. So I wrote them there to make sure that we know that we discussed that. So what I have left is n plus 3 equals 3. And now I've got to go back all the way through our sad meg again, right? Do I have any subtraction or addition to do?
Plus 3.
I do have plus 3. How do you get rid of plus 3?
Minus 3.
Subtraction property of equality.
Minus 3, minus 3. 3 minus 3?
0.
0. What's left? N equals
0.
nothing?
No, it's a 0.
Gotta make sure it's 0. N equals 0.
Hey, we got it last time.
See? So basically what you were saying is whatever one we find easier we should do.
Yep. They both equal 0 over here on the left-hand side, going through step 0, 1, and 2. Simplify, get rid of the constant, get rid of the coefficient. Got us the same answer as going through SADMEG.
Cool.
Sometimes one is going to be easier than the other. This is kind of about the same either way. I prefer this way because 12 is divisible by 4.
I'm the most awesomest person. Nerds rule the world. Don't ever forget that. All right. So, the question I always get when I'm teaching it is, Miss Greg, because that's how kids talk to me. It's kind of like you guys always hear like teacher going, ma'am, 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 ma'am. All I hear is, Mr. Greg, Mr. Greg, where would I ever use this? Well, the reality is that algebraic problems don't just magically pop up on things. You have to create them. They come from situations, and you have to create a problem to solve them. That's why these things were originally created. So it says the angle sum of a triangle is 180 degrees. Hopefully you know that. What they're talking about there is that if I take all the angles inside of a triangle, no matter what kind of triangle it is, if it is a triangle, the sum of all the angles will equal 180 degrees.
I sure hope they.
Hopefully you learned that like in like the 5th grade, maybe 6th, I don't know. If you forgot, just here's a reminder, it's 180 degrees. So if I want to find the value of this x and this x, so 9 times this x is this angle, and 30 plus this x is this angle, if I want to find out what x is, I have to create an equation so I can figure out what that is. And you say, well, how do I do that? Well, I know that this whole triangle equals, you got it, 180 degrees. So I can set my equation equal to 180 degrees. Now, all I got to do is to find the sum of the angles. Sum means addition. So I'm going to be doing what to each angle? Adding. So I'm going to go 30 degrees plus 9x degrees plus parentheses 30 plus x degrees. Now, if you decide to add the degrees at the end of the equation, that's fine. It's up to you. If you want to just rewrite that equation and put the degrees in at the end, that's fine. As long as in your final answer you have degrees. Sometimes people like to take that away because it just looks weird.
It's like the power of 0.
The power of 0. Now I have this equation, and this is the very definition of a multi-step equation. I can't just circle the variable and solve, because if you look carefully, you can see there's an x here and there's an x here. So I can't just circle the variable, underline the coefficient, and get rid of the constant. Before I do that, I have to simplify. So let's try doing this. You want to do SADMEG? We're going to solve it the old-fashioned way. The old-fashioned way says, I do a lollipop, ba-dum, bum, bum, and that divides the equation to 2 sides. Then I'm going to look at this side, and I'm going to add like terms. And so to do that, I have to go through the equation, and I'm doing GEM-DOS. That's simplifying. GEM-DOS. And you notice that I put the multiplication, division, adding, subtraction over each other. The reason why I did that is because whatever I see first. So I look through and say, is there any grouping symbols?
Yes.
There are. That's right there, right? The thing is, in this case, I can't do what's inside them because it's a 30 plus x, and I don't know what x is. However, to get rid of grouping symbols, we do something called the distribution problem. A property, not problem. And so I would distribute through, but really the only thing out front of this parentheses is what? Who can tell me what's outside of these parentheses?
Plus sign.
A plus sign, really, there's this magical one. It's there all the time. It's just this weird thing that's everywhere. This ghost one. And that one, it's really plus 1 times that. And so if I was to distribute that 1 through, you would find that I just get 30 plus x. So those parentheses weren't really necessary. Over here they were because I knew that this term was 30 plus x. But in the problem, they kind of just go away. So I can rewrite this problem. And this is the exact same problem. I just dropped the parentheses. Now, if I wanted to go through all the steps, I would probably do the associative property of addition, and I would rearrange the entire problem, putting the variables together and the constants together. But if we want to take a shortcut of that, because we're in Math Secondary 1, I can say, okay, I see I have 9 x's and an x. And how many x's are right here? Remember that invisible. So 9 x's plus 1 x gives me 10 x's. You're dating too much if you have 10 x's. All right, next, I got to look at my constants. I look at this side of the equation, and I see because I have a constant over here, but I'm looking at this side. I'm simplifying this side of the equation. 30 plus 30 is 60. So I have 60. I bring down the 180 degrees, and boom, all of a sudden my multi-step equation became a two-step equation. And to solve a two-step equation, all I got to do is do the things that we've learned before. Step 0 is just to identify the variable. The variable is the letter. There's only one letter. Remember, people get confused. That's not a letter. That's an equal sign. It's a symbol. This is not a letter. This is an addition sign. That is a operation. The only thing that's not a number here is the x. That makes it the variable. I can circle my variable. Oh, and that's the same color as that, so I'm going to make it blue. After I've circled my variable, it becomes easier to find the coefficient. The coefficient is the thing that's always touching the variable. You say, well, how do you know it's touching it? Because this plus sign with the 60 is saying the 60 is like, oh, I don't think so. Stay away from me. But the 10 is like, hi. It's kind of creepy, right? So I now know that 10 is the coefficient. It gets one line. And then the final thing is the constant. I have a constant on this side and a constant on that side. But remember, when we're solving equations, we look to the same side of the equation as the variable. And whatever's on the same side but doesn't touch, that's the constant. Some people like to think of it, it's the thing that's not the coefficient. Because the coefficient's pretty easy to tell. So now I have 2, 1, 0 to solve. The two lines is get rid of the constant. So I got to do that first. How do I get rid of plus 60?
Minus 60.
If I minus 60 from this side, I have to do it to the other side because like a teeter-totter or a seesaw, depending on where you came from, or a double balance beam, you have to do it to both sides. 60 minus 60, well, that is 0. But I don't need to write the 0 down because that's silly. But I do bring down, you don't tell people, hey, I'm 14 plus 0. They would look like you're crazy. It's true, you might be 14 plus 0, but people are kind of going to stare at you and kind of think you're crazy. I bring down the 10x. I bring down, after I solve this, 180 minus 60 leaves me 120. And notice I brought down my 10x directly to below because I like to keep track of my steps. So I've taken care of the constant. Step 1, 2, 1, 0 is get rid of the coefficient. The coefficient in this one is 10 because it's touching the variable. And how do I get rid of times 10? I divide by 10. If I divide one side by 10, I got to divide the other side by 10. 10 divided by 10 equals 1. But I don't need to put a 1 there. Just like you don't ask for 1 salt shaker, you just say pass the salt. It's assuming you mean 1. Nobody's going to pass you 8 salt shakers if you say pass the salt. So it's just x. And then 12 divided, that's the answer. 120 divided by 10 is 12. And that is my solution. 2, 1, 0 is my solution. X equals 12. That's how you do that. Hopefully you can do the activity. If you have any questions, remember, don't talk to me. Talk to Miss Garcia.
Do it.
Do it.
I dare you.
Dare you. That's it. Multi-step learning activity online. Get it done.
It's 2:30.